Hello guys, may the peace and blessing of Allah be upon you all, and today we will continue learning how to solve the quadratic equation, but today we will solve the quadratic equation by the general formula, or sometimes we call it the quadratic formula. So stick around and keep watching. When you factor an equation which is hard to factor, then it's the magic for the quadratic formula. But what is the quadratic formula? Before mentioning the quadratic formula or the general formula, we should know that making the equation is equal to 0, it's better for the quadratic formula. I mean that making the quadratic formula in the standard form, like ax squared plus bx plus c is equal to 0, now we are ready for mentioning the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. What are a, b, and c? Yeah, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. All right, and now I will show you how that works with the quadratic formula in the next example, so stay tuned. Find in R the solution set of each of the following equations. 5x squared plus 2x is equal to 4. Now here, if you noticed that the equation is not in the standard form, I mean you have is equal to 4 on the other side, but it should be 0. So we have to move 4 to the other side in the opposite sign to make it equal 0, right? So 5x squared plus 2x, I'm moving 4 to the other side, it will be negative 4. So negative 4, and then is equal to 0. Now it's in the standard form. Ax squared plus bx plus c is equal to 0. A is the coefficient of x squared, which is 5. So a is equal to 5. And b is the coefficient of x, which is 2. So b is equal to 2. And c is the constant term, which is negative 4. So c is equal to negative 4. But make sure that each number should be taken with the sign, if it's positive or if it's negative. So here, for example, c is equal to negative 4, not 4, right? Now, what is the quadratic formula? As we mentioned before, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, just plugging in all of the values that we get in right now, a and b and c, and instead of writing a and b and c. So negative b being negative 2 plus or minus the square root of b squared, which is 2 squared, minus 4ac, which is minus 4 times 5 times negative 4. A is 5 and b, or I mean c is negative 4. All over divided by 2a, 2 times 5. All right, so negative 2 plus or minus 2 squared, which is 4, and negative 4 times 5 times negative 4 is plus 80 divided by 10. Now 4 plus 80 is 84, so negative 2 plus or minus the square root of 84 divided by 10. But you can simplify the square root of 84, right? The square root of 84, if you can factor 84 as two factors, but one of them is, or one of them had a square root, like 4 times 21. You have a square root for 4, and you don't have a square root for 21, right? So the square root of 4 is 2, and keep 21 under the square root. So it's equal to 2 square root of 21. All right. So again, x is equal to negative 2 plus or minus the square root of 84 divided by 10. Plugging in the value of the square root of 84, it will be negative 2 plus or minus 2 square root of 21 all over 10. All right, now we can simplify and reduce the numerator and the denominator by getting 2 out as a factor, all right? So 2 out of the parentheses, and then divide each term by 2. Negative 2 divided by 2 is negative 1, plus or minus, and 2 square root of 21 divided by 2 is the square root of 21. 2 and 2 cancel each other out. Divided by 10. Someone will tell me that we have a factor also between 2 and 10. That's right. So we can reduce 2 and 10 by dividing by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So again, x is equal to -1 plus or minus the square root of 21 divided by 5. But you have plus or minus, right? So we can break up the expression into two parts. One is a plus and the other is minus. It's easy. So now x is equal to -1 plus square root of 21 divided by 5. And on the other hand, x is equal to -1 minus the square root of 21 divided by 5. All of these are just if you didn't use the calculator. But if you use the calculator, I think everything will be easy. So just type it on the calculator and get what is the answer or what is the response on the calculator and put it here in the solution set. So the solution set is equal to -1 plus the square root of 21 over 5 and -1 minus the square root of 21 divided by 5. Or if you typed it in the calculator or on the calculator, you will get it in decimal or as a fraction. It's up to you. All right. Find in R the solution set of each of the following equations. X times x minus 4 is equal to 3. And I have a question for you. Is that equation in the standard form? You're right. It's not in the standard form ax squared plus bx plus c is equal to 0. Right. So we have two problems here. The first problem is we have x outside of the parentheses. So it's not in the original form. So we have to distribute x into the expression or into the parentheses. I mean x times x and then x times -4. All right. X times x is equal to x squared and x times -4 is -4x is equal to 3. Is it in the standard form now? Nope. So we have to move 3 to the other side to make it equal to 0. You're right. So x squared minus 4x minus 3 is equal to 0. And now it's in the standard form. What is the values for a, b, and c? A is equal to 1. Right. A is the coefficient of x squared. And b is the coefficient of x, which is -4. You're right. And then c is equal to -3, which is the constant term. Now, plugging in all of these values in the quadratic formula or the general formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. -b is -4, and you remember negative times negative is positive, plus or minus the square root of b squared, I mean -4 squared, but remember that put the negative inside the parentheses because the power of 2 is over b, I mean over the whole number with the sign of the number. Minus 4ac minus 4 times 1 times -3 all over 2 times a, which is 2 times 1. All right. So 4 plus or minus the square root of -4 squared, which is 16, and -4 times 1 times -3 is plus 12 all over 2 times 1, which is 2. All right. So 4 plus or minus the square root of 16 plus 12 is 28 all over 2. All right. So can you simplify the square root of 28? Can be written in the form of two factors, but one factor has a square root. Yeah, sure. So 28 is equal to 4 times 7 because 4 has a square root. And the square root of 4 is 2. So getting out 2 outside of the square root. So it's 2 the square root of 7. So repeating it, that expression one more. So 4 plus or minus 2 the square root of 7 all over 2. And now you have 2 as a factor in the numerator. You remember? So 2 as a factor will be 2. And inside the parentheses, you will divide each term by 2. 4 divided by 2 is 2. And 2 the square root of 7 divided by 2 is the square root of 7 because 2 and 2 cancel each other out. And the denominator will keep it as it is. So it's 2. It's still 2. What did you notice here? Yeah, we have 2 in the numerator and 2 in the denominator, so cancel each other out. So x is equal to 2 plus or minus the square root of 7. But you have plus or minus. Yeah, break it up into two parts. X is equal to 2 plus square root of 7 and 2 minus square root of 7. All right. So is the solution set now? The solution set is equal to the square root of 2 plus the square root of 7, or x is equal to, the other element, 2 minus the square root of 7, or you can get it by the calculator and get it in decimal. All right. Find in R the solution set of each of the following equations by using the general formula approximating the result to the nearest tenth. Just a remark here to round a number or round a decimal number to the nearest tenth or hundredth or thousandth. For example, if I have a decimal number 5.312, and if I need to approximate this number to the nearest tenth, and the same thing holds true for hundredths and for thousands, but I will just show you how that works with the tenth. First, underline the tenth. Where is the tenth? 5 is the ones, 3 is the tenth, 1 is the hundredth, 2 is the thousandth. So underline the tenth, which is 3, and then look at the digit to the right, which is 1. If that digit is 5 or more, and they are calling rich digit, 5, 6, 7, 8, and 9. If that digit is 5 or more, so you will round up. I mean that you will add 1 to the 10th place. And if that digit on the right, if that digit is less than 5, I mean 4, 3, 2, 1, or 0, they are calling it poor digits, that means you round down. I mean that you will keep 3 as it is. So now here, 1 to the right of 3 is less than 5. So you round down or keep 3 as it is. So it's 5.3. And cut out or cut off all of the numbers or all of the digits on the right. I mean cut off 1 and 2 because they are becoming zeros. So there is no need to write down zeros. All right. Another example, 2.76 to the nearest tenth. All right. Underline the tenth, which is 7, to the right of the decimal place, and then look at the digit to the right, which is 6. If that digit is 5 and more, or it is less than 5, it's 5 and more. So you will round up 7, it will become 8. You will add 1 to 7, it will be 8. So the answer will be approximately 2.8. Now the equation is 2x squared plus 3x minus 4 is equal to 0. Is it in the standard form? Of course, yeah. Ax squared plus bx plus c is equal to 0. So what are the values of a, b, and c? A is the coefficient of x squared, a is equal to 2, b is the coefficient of x, which is 3, and c is the coefficient of, or the constant term, which is negative 4. Remember, it's negative 4, not positive 4, because it has a sign of negative. All right, so the formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in all the values in the formula. So negative b, which is negative 3 plus or minus the square root of b squared, which is 3 squared minus 4ac, which is minus 4 times 2 times negative 4. A is 2 and c is negative 4. All over 2a, which is 2 times 2. Just doing the math here under the square root, 3 squared means 9. Negative 4 times 2 times negative 4 is positive 32 all over 2 times 2, which is 4. All right, so negative 3 plus or minus the square root of 9 plus 32 is 41 all over 4. But here in the question, remember, approximating the result to the nearest tenth. So get it in the calculator and then round up or down. Now, negative 3 plus square root of 41 divided by 4, or negative 3 minus square root of 41 divided by 4, just breaking up into two parts. One is positive, and the other is negative. By getting that in the calculator, we get 0.85. Is that true? Nope. You have to round it. You remember? Round it to the nearest tenth. Where is the tenth? Where is the 10th place? Yeah, the 10th place is 8. So look at the digit to the right of 8, which is 5. Yeah, it's 5. 5, 6, 7, 8, 9. Round up. 4, 3, 2, 1, 0. Round down. So now here you will round up. So it will be 0.9. All right. On the other side, negative 3 minus square root of 41 divided by 4, which is equal to negative 2.35. I mean 35. So is that in the rounding form? Nope. So we have to round it. Where is the 10th place? Yeah, the 10th place is 3. So looking at the digit to the right of 3, which is 5 also, so you round up. I mean, you will add 1 to 3 to be 4. So it's negative 2.4. So the answer, or the solution set, is equal to negative, 0.9 or negative 2.4. All right. Find in R the solution set of each of the following equations by using the general formula approximating the result to the nearest tenth as the previous example. Now we have 3 over x minus 2 plus 2 over x plus 2 is equal to 2. Is that in the standard form? Of course, no. Basically, it's not in the standard form at all. But let's focus on the problems that we have. What are the problems that we have? Yeah, we have x minus 2 as a denominator in the first fraction, and we have x plus 2, which is the second denominator in the second fraction. So first, we have to get rid of these denominators. All of these denominators we have to get rid of. So how to get rid of these denominators? Think about that. You can pause the video here and think about that, how to get rid of these denominators. Yeah, you are right. So to cancel these denominators, we have to multiply by all of these denominators. X minus 2 times x plus 2, which is LCD, lowest common denominator. So rewriting the equation 3 over x minus 2 and write it separately because later we'll multiply. And then plus 2 over x plus 2, and then a break, and then it's equal to 2. Now we have to multiply by x minus 2 times x plus 2 in each side. So here in the left-hand side, you have to multiply by the first fraction, x minus 2 times x plus 2, and then here times x minus 2 times x plus 2, and also on the right times x minus 2 times x plus 2. All right. What did you not notice here on the left with the first fraction, 3 over x minus 2? Yeah, you're right. You have x minus 2 in the denominator and x minus 2 in the numerator. So cancel each other out. So you have left with 3 times x plus 2. And then the same thing holds to x plus 2. So x plus 2 in the denominator and x plus 2 in the numerator cancel each other out. You have left with 2 times x minus 2. And on the right-hand side, you have 2 times x minus 2 times x plus 2. All right. And here, instead of multiplying each term by the other term in the next parentheses, I mean, instead of multiplying x times x and x times 2 and negative 2 times x and negative 2 times 2, you notice that this is a difference of two terms multiplying by the sum of them. So you just multiply the first term by the first term and the second term by the second term. X times x is x squared, and negative 2 times 2 is negative 4. And don't forget you have 2 outside of the parentheses. And keep the left-hand side, 3x plus 6 plus 2x minus 4. All right. And as long as you have 2 outside, so just distribute 2 into the expression. 2 times x squared is 2x squared, and 2 times negative 4 is negative 8. And now we have, on the left-hand side, you have like terms, the like terms that has the same variable. You have 3x plus 2x. These are like terms. And also the constant terms are also like terms, 6 minus 4. because this is a number and this is a number. So 3x plus 2x is 5x, or 5x, sorry, and 6 minus 4 is 2, and on the other side you have 2x squared minus 8. Rearranging the expression one more, by getting 5x plus 2 to the other side, so 2x squared minus 8 minus 5x minus 2 is equal to 0. You know that you have two numbers, negative 8 minus 2, which is negative 10. So the final equation is 2x squared minus 5x minus 10 is equal to 0. Now, is it in the standard form? Yeah, it is in the standard form. Now, as usual, a is equal to the coefficient of x squared, 2. Now, I think you mastered how to solve it with the quadratic formula. B is equal to negative 5, C is equal to negative 10. I'm plugging in the formula x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Negative b, which is negative times negative 5, plus or minus the square root of b squared, which is negative 5 squared, minus 4ac minus 4 times 2 times negative 10 all over 2 times a, which is 2 times 2. Doing the math under the square root, negative 5 squared, which is 25, and negative 4 times 2 times negative 10 is 80. So under the square root, you have 25 plus 80, which is 105. Now, breaking it up into two parts with plus and minus. So 5 plus square root of 105 all over 4, and x is equal to 5 minus the square root of 105 all over 4. And here, getting the result of the first value, x is equal to 3.8, and here x is equal to negative 1.3 by getting that in the calculator and then approximating to the nearest tenth. So the solution set is equal to 3.8 and negative 1.3. All right.